How's it going, everyone? My name is Garth Turner, and I am part of the 24th cohort at the Data School. And today I'm going to be telling you a little bit about Snowflake and mostly how it can be used as an ETL versus ELT tool. ETL refers to extract, transform, and load, whereas ELT is just a slightly swapped around version of that, which is extract, load, and transform. So before we get into Snowflake as an ETL versus ELT process, let's just do a little bit of recap as to what Snowflake is and how it can be used. Snowflake is a SQL database built for the cloud, which means it is a full cloud data platform. It is primarily used as a cloud-based data warehouse, although it can be used as a data lake if required. It allows you to have multiple databases from multiple locations. So just to recap, a data warehouse is a collection of databases storing lots of different types of data from various sources. So basically, multiple people can own multiple different sources of data all in one place. A database is an organized collection of tables that contain rows and columns of structured data. And lastly, a data lake is a repository where structured and unstructured data is stored before it is brought into a data warehouse. So it's almost like a dumping ground of data. In Snowflake's case, these dumping grounds are called stages. Snowflake's data cloud is powered by an advanced data platform provided as software as a service, or SaaS, which is commonly referred to. Snowflake enables data storage, processing, and analytic solutions that are faster, easier to use, and far more flexible than traditional offerings. This is one of the main reasons why it is such a rapidly growing software. The Snowflake data platform is not built on any existing database technology or big data software platforms such as Hadoop. Instead, Snowflake combines a completely new SQL query engine with an innovative architecture natively designed for the cloud. To the user, Snowflake provides all of the functionality and an enterprise analytic database, along with many additional special features and unique capabilities. So Snowflake is essentially a true software as a service offering for the following reasons. There's no hardware, virtual or physical, to select, install, configure, or manage. There is virtually no software to install, configure, or manage. And lastly, ongoing maintenance, management, upgrades, and tuning are handled by Snowflake themselves. Snowflake runs completely on cloud infrastructure, and all components of Snowflake service, other than optional command line clients, drivers, and connectors, run in public cloud infrastructures. Snowflake uses virtual compute instances for its compute needs and a storage service for persistent storage of data. Snowflake cannot be run on a private cloud infrastructure, such as a local server owned by a company. So now let's talk a little bit about Snowflake's innovative architecture. It is a hybrid of traditional shared disk and shared nothing database architectures. Similar to shared disk architectures, Snowflake uses a central data repository for persisted data that is accessible from all compute nodes in the platform. But similar to shared nothing architectures, Snowflake processes queries using MPP, which stands for massively parallel processing. It uses MPP compute clusters where each node in the cluster stores a portion of the entire dataset locally. This approach offers the data management simplicity of a shared disk architecture, but with the performance and scale-out benefits of shared nothing architecture. Snowflake's unique architecture consists of three key layers, namely database storage, query processing, and cloud services. So the first one, the database storage or centralized storage, is where data is loaded into Snowflake and reorganized into Snowflake's internal optimized compressed columnar format. Snowflake stores this optimized data in cloud storage. Snowflake also manages all aspects of how this data is stored. The organization, file size, structure, compression, metadata, statistics, and other aspects of data storage are handled by Snowflake itself. The data objects stored by Snowflake are not directly visible nor accessible by customers. They are only accessible through SQL query operations run using Snowflake. The next layer is the query processing or multi-cluster compute layer. This is where query execution is performed in the processing layer. Snowflake processes queries using virtual warehouses. Each virtual warehouse is an MPP compute cluster composed of multiple compute nodes allocated by Snowflake from a cloud provider. Each virtual warehouse is an independent compute cluster that does not share compute resources with other virtual warehouses. As a result, each virtual warehouse has no impact on the performance of other virtual warehouses. And the last layer is the cloud services layer or scale-out services layer. And this cloud services layer is a collection of services that coordinate activities across Snowflake. These services tie together all of the different components of Snowflake in order to process user requests, from login to query dispatch. The cloud services layer also runs on compute instances provisioned by Snowflake from the cloud provider. I'll be working in the Information Lab Snowflake instance later on. So some of the services managed in this layer include authentication, infrastructure management, metadata management, query parsing and optimization, and access control. So when connecting to Snowflake, there are various different ways to do so. Firstly, there's a web-based user interface from which all aspects of managing and using Snowflake can be accessed. There are command line clients, for example, SnowSQL, which can also access all aspects of managing and using Snowflake. You can use ODBC and JDBC drivers that can be used by other applications, for example, Tableau, to connect to Snowflake. You can use native connectors, for example, Python or Spark, that can be used to develop applications for connecting to Snowflake. And lastly, there are third-party connectors that can be used to connect applications such as ETL tools and BI tools. So why do we use Snowflake? Firstly, for the performance and speed, as well as flexibility, accessibility, data sharing capability, and high availability. And lastly, some of the Snowflake editions. There's the Standard Edition, Enterprise Edition, Business Critical Edition, and Snowflake Private Virtual Edition. Cool, so now let's start talking about ETL and ELT, what they are and how Snowflake can be used for both. So both ETL and ELT are a series of processes that prepare data for analysis and additional processing to provide actionable business insights. ETL stands for extract, transform, and load, a combination of the three data engineering processes that move data from one database, multiple databases, or other sources to a unified repository. The three processes of ETL are firstly extraction, in which raw data is pulled from a source or multiple sources. Data could come from transactional applications such as a customer relationship management data from Salesforce, or enterprise resource planning data, Internet of Things sensors that gather readings from a production line or factory floor operation. And this extracted data may be in several formats such as relational databases, XML, JSON, and various others. The next stage is the transformation stage, in which data is updated to match organizational needs and data storage solution requirements. Transformation can involve converting all data types to the same format, cleansing by removing inconsistent or inaccurate data, combining data elements from multiple data models, pulling in data from other sources, and various other processes. During this transformation stage, rules and functions are applied and data cleansed to prevent including bad or non-matching data to the destination repository. And then the last stage is the loading stage, in which data is delivered and secured for sharing, making business-ready data available to internal and external users. This process may include overwriting the destination's existing data. So the ETL process looks something like this. We have our extraction, where data sources from various different places are pulled in. It is then transformed, which may include filtering or aggregating or anything that may need to be done to the data so that it is ready for use. And then finally, it is loaded up. In this case, it would be loaded into Snowflake. ELT is a variation of ETL in which data is extracted and loaded before it is transformed. This sequence allows businesses to preload raw data to a place where it can be modified. ELT is more typical for consolidating data in a data warehouse, as cloud-based data warehouse solutions are capable of scalable processing. So although reordering the steps of the traditional ETL series to ELT may seem trivial, loading data to its destination before transforming it does have several advantages over transform then load. So some of these advantages include more flexibility, as ETL is traditionally intended for relational structured data. Cloud-based data warehouses enable ELT for structured and unstructured data. There's greater accessibility, as ETL is generally supported, maintained, and governed by organizations' IT departments, whereas ELT allows for easier access and use by employees. There are scalability benefits, as ETL can be prohibitively resource intensive for some businesses, whereas ELT solutions are generally cloud-based software as a service available to a broader range of businesses. There are faster load times, as ETL typically takes longer as it uses a staging area and system, whereas with ETL, there's only one load to the destination system. There are faster transformation times, as ETL is typically slower and dependent on the size of the datasets, whereas ELT transformation is not dependent on data size. And then lastly, there's less time required for data maintenance, as data may need to be resourced and reloaded if the transformation is found to be inadequate for the data's intended purposes, whereas with ELT, the original data is intact and already loaded should additional transformation be necessary. So Snowflake supports both ETL and ELT and works with a wide range of data integration tools, including Informatica, Alteryx, and Tableau. New tools and self-service pipelines are eliminating manual ETL coding and the need for outsourced data cleansing services. Whether with the easy ETL and ELT or no ETL options via Snowflake, data engineers can spend more time working on critical data strategy and pipeline optimization projects. So the question always arises, which is better? And this will always lean toward the side of user preference. Many people feel strongly one way or the other, and both can be effective tools to ingest data into a data warehouse. So now that we have covered some of the background with regards to Snowflake and the ETL and ELT processes, we are now going to jump in and start demonstrating how they can be used as tools using Snowflake. Cool. So now that we have discussed Snowflake a little bit, and sort of what it does and how it can be used in an ETL tool and an ELT tool, let's do some examples of how it can be performed in both ways. So firstly, we're going to go through the ETL process, which, as you remember, is the extract, transform, and load process. And to do that, we're going to use another piece of software called Alteryx, which I'm sure some of you are familiar with. And we're just going to take two files from my computer, join them together, do a little bit of transformation, and then load it up into Snowflake. And that'll sort of complete our whole ETL process. So to do that, I am going to use two input tools, and we're going to go and select our two files from my laptop. So if I open this up and go to my files, we're going to select our first file, which is the boys file, and the second one, which is the bands file. Because who doesn't love a good boy band? Cool. So now you'll see we have our boys data, which is a list of all the different members of these boy bands, as well as some other information about them, including hair color, instruments, and etc., etc. And then our bands data, which has some detail about the band, their highest song, the highest position of their song, and then some other information. So the transformation that we want to do is take these two data sets and join them together so that we can get a data set that tells us the band name, the number of members, their highest song, and the highest song position. So firstly, to do that, what we're going to need to do is choose only the fields that we want to see. So I'm going to use two select tools to do that. And in the first data set, we're just going to select band, name, and then remove all the rest, because that's all we really need from that data set. And then likewise for the second one, we are going to just select band, highest position, and highest song, and get rid of the rest. Cool, so now you'll see that we have our band name and the member's name, and then in our other data set, we have our band name, its highest position, and the highest song. So the next step is obviously to join them together. So I'm going to use a join tool,
and I'm just going to connect these up. And the field that we're going to connect them on is a band field. And now if we run that, you'll see we have our band, the name of the member, the highest position, and the highest song. But what we really want is a field that tells us just the number of members in that band. So to do that, I am going to use a summarize tool and drop that in there. And we're going to group by our band name, our highest position, and our highest song. Add a group by, and then because we just want a count of the members, we're going to do a count on the member name. And let's call that new field number of members. Cool, so if I run that, you'll see we have the band, the highest position of their highest song, and the number of members. So now for the last part of the ETL process, which is the load stage, we're going to use an output tool to load our data up into Snowflake. So if I drag and drop an output tool there, then we're going to write it to a database. So if I navigate to the different selection of data sources, you'll see there are tons of different ones to choose from, but we obviously want Snowflake. So if I scroll down, you'll see Snowflake is over here, and there's an option to connect via a bulk load or just an ODBC connection. So I'm going to select bulk, and over here you'll see I have my data source that I've created in Snowflake, which is Garth_Snowflake. And if I show you the configuration of that, we see that I have been able to fill in my user instance, which is just my til email address, my server name, the database that we are connecting to, which is the til_dataschool database, the schema, which is DS24, which is my cohort, and then the warehouse. So if I click OK there, and I change this over to a local staging method, just so that the data won't hang around after this demo is finished, then it requires me to give the new dataset a name, which I'm going to call boy bands. So if I click OK and I run this, what's going to happen is Alteryx is now going to reach out to Snowflake, ask me to sign in, and then it is going to upload the data. So now if I go over to my Snowflake instance, then I can refresh and the new boy bands dataset should now be there. And now what we can do is we can use this data in any way possible from Snowflake because it has now been loaded into one of the warehouses. So that's essentially how ETL works with Snowflake. The extraction and transformation is performed outside, and then it is loaded up into Snowflake from where it can be used. Okay, so now let's look at how we can use Snowflake for an ELT process. And there are a number of ways to do the sort of E and L phases, so the extraction and loading. And in this case, I've used a SnowSQL command, which is SnowSQL is something that you have to download onto your computer, and then you can use your command window to push up files into a stage that you create. So firstly, I created the stage, which I've called ELT demo stage. I specified the file format, which is obviously CSV, and then just added some parameters that will delete this the data from the stage once it has been created in a table. So that's kind of like the dumping ground where the data is kind of stored before you create a table, and I basically just want to get rid of the data once I've created the table in Snowflake. So once I've created this stage, then I can go over into my command window and basically push up the separate files using SnowSQL. So over here, I've pushed up the bands CSV, and then over here, I've pushed up the boys CSV. So this is taking that data from my laptop and pushing it up into SQL into my specified stage that I have created. Cool. So once that data is now in Snowflake, you can see it's over here being stored. I have my bands CSV and my boys CSV. I can now create two tables that I can then use. So if you remember in Alteryx, we took the boys data, took the bands data, selected the columns we wanted, and then created that small summarized table. So the first step in this case would be writing a SQL query to create my bands table. So over here, what I'm doing is I'm creating a table, I'm calling it bands, and I'm selecting the various fields which I want to be in this bands table. So firstly, I've selected field 1. I've gotten rid of the quotation marks because when I pushed it up using SnowSQL, it's added on quotation marks. And I'm naming that band, and then I'm selecting the second field, naming it highest position, and then the fourth field and naming it highest songs. And I'm selecting that from our ELT demo stage from specifically the bands CSV. So if I run this, the query will execute, and you'll see here it has executed successfully. And if I refresh my tables within the DS24 schema, you'll see my bands table has now appeared. Cool, so then the next step is to create the boys table, which follows a very similar process. Create table, name it boys, select the specific fields I want, which in this case are band and name, and then specify where you want to get these fields from. So let me run this query as well. Executed successfully, refresh, and you'll see now I have my boys table. You'll see my boy bands table that I pushed up from Ultrix is still sitting over here. Cool, so the next step that we did in our transformation was joining them. So what I want to do when I join them is I just want to create a view. So a view is different to a table in that it's not stored data as a table. It's more just a query that'll show you data in a specific format, which is what I want to do before I go ahead and create the table I want at the very end. So to do that, I'm going to create my view. I want to call it summary boy bands, and I'm going to select the certain fields that I want. So I want to get my band, I want to get my highest position, my highest song, and my name. And I'm just calling my two different tables D and O because they have a similar field band, and I want to join on D.band and O.band. So what that's doing is joining the band field from my bands table onto the band field from my boys table. So if I go ahead and run that, you'll see in my views over here, a summary boy bands view has now appeared. So if I preview that data, you'll see it's gone ahead and joined those two tables to create this specific view that tells me my band name, my highest position, my highest song, and the name of the band member. But if you remember, we don't want to see the name of the band member. We just want a specific number of members in each band. So to get that, I have to do one final query, and basically what I'm going to do is I'm going to select band from this view. I'm going to select the count of the name field, and I want to call that number of members. I'm going to select the highest position as highest position. I do a max calculation here because it's just a string field and I just want it to pull back one, and I have to aggregate it in some way. So I get the max as highest position and then the max of highest song as highest song. And because those are all the same in both fields, it's just going to bring back that specific value. And then I need a point to where I want to get this data from. So I'm looking at the database tool underscore data school, the schema that I'm in, which is the DS24 schema, and the view summary boy bands. And then I just want to group lastly by the band name, which is my band field. And if I run that now, you'll see this query has given me the same data set that I created in Ultrix with my band name, the number of members, the highest position, and the highest song. And that is how I've done my transformation now directly in Snowflake, as opposed to doing the transformation from somewhere else. So this shows you how Snowflake can be used in both ways, and it's highly dependent on, user preference in terms of which one you want to use. This can be very useful in terms of just getting all the data up into Snowflake and not really worrying about it. If there's not that much data, then you can afford to have a whole bunch of it just sitting in your Snowflake instance and then querying it how you will with these SQL queries. But if it is a large data set, sometimes it can be more beneficial to do the transformation before you push it up into Snowflake, so that you're not sitting with tons of data that you're not going to actually use.
Thanks very much for watching, guys. If you enjoyed this video and want to learn more about Snowflake, then head over to the Data School blog, where there are tons of articles which will teach you all about Snowflake, Tableau, and Alteryx from various different data schoolers. The Snowflake website also has a bunch of training that you can watch or read along with, or else just carry on browsing through the different videos we have here on the Information Labs YouTube channel.